number system. Our today's plan of study is decimal to binary conversion. Decimal number system is a base 10 system which uses 10 basic symbols 0 to 9. The weight values are represented in powers of 10. If we move towards the left of the decimal point, then the power of 10 increases starting from 0, and if we move towards the right of the decimal point, then the power decreases. Whereas the binary number system is a base 2 system which uses two basic symbols 0 and 1. The weight values are represented in powers of 2. If we move towards the left of this binary point, then the power increases starting from 0, and if we move towards the right of this binary point, then the power decreases. Decimal to binary conversion methods. Usually, two methods are used. The double method, which is also known as the method of repeated division by 2 and repeated multiplication by 2. And the another method is known as the sum of weight method. In case of double method, we have to verify the number is an integer number or a fractional number. If it is an integer number, then the repeated division by 2 is to be followed, and in case of fractional number, the repeated multiplication by 2 is to be followed. For a mixed number, the integer part is to be converted to binary by using the repeated division by 2 method, and the fractional part is to be converted to binary by using the repeated multiplication by 2 method, and finally they are to be combined accordingly. Today we will concentrate our discussion on double method. Let us take an example 11 in decimal. What will be its binary equivalent? Since it is an integer number, so the repeated division by 2 is to be followed. We have to divide the 11 by 2, then the quotient will be 5, the remainder will be 1. This one is known as the least significant bit or the LSB. If we divide the 5 again by 2, then the quotient will be 2, remainder will be 1, and perform the same operation, then here the quotient will be 1 and the remainder will be 0, and for this the quotient will be 0 and remainder will be 1. This one is known as the most significant bit for the MSB. Now we have to read off. So the binary equivalent of decimal 11 is 1011. Let us take another example of fractional number 0.25. What will be its binary equivalent? Since it is a fractional number, then the repeated multiplication by 2 is to be followed. We have to multiply the 0.25 by 2, we will get 0.50. We have to taken away the 0 which is appearing before the decimal point, and this 0 will be the MSB or the most significant bit for this. Again, if we multiply the fractional part 0.50 by 2, then we will get 1.00. Since 00 is appearing, so further multiplication is not required, since that will produce the same thing again 00. In this case, the 1 is to be taken out since it appears before the decimal point, and this one is considered as the least significant bit or the LSB, and we have to read down. Then the binary equivalent of 0.25 will be 0.01. Now let us take another example of mixed numbers, which is 25.625 in decimal. What will be its binary equivalent? Here the integer part is 25. In that case, we have to follow the repeated division by 2. And if we perform this operation, then 1 will be the LSB. And for this case, performing the same operation, we will get 1 as the MSB. And then we have to read off. So the binary equivalent of 25 will be 11001. Now the fractional part. For that we have to follow the repeated multiplication by 2. If we multiply 0.625 by 2, then we will get this. In this case, we have to take the 1, and which is considered as the MSB. Then we have to perform the same operation. We will get it. 0 will come out, and if we, in this case, we find that 1 is the LSB, and we have to read down. So the binary equivalent of 0.625 will be 0.101. Now combining these two, we will get 11001.101, which is the binary equivalent of 25.625. Now consider another example, 100.35 in decimal. What will be its binary equivalent? We have to follow the same process. Here 100 is the integer part. If we follow this, then 0 will be the LSB, and by following the repeated division by 2, we will get it. Here MSB is 1, and we have to read off. So the binary equivalent of 100 will be 1100100. Now for the fractional part, we have to perform the repeated multiplication by 2. If we multiply the 0.35 by 2, then we will get 0.70. 0 will be the MSB, and we have to perform it, the repeated multiplication. Look at this, 0.80, 0.80, and if we perform the repeated multiplication, then this will be repeated again and again, 0, 1, 1, 0. So it will not be concluded. We have to terminate it somewhere. So some source of error will be introduced, that is known as the truncation error due to this termination, and the last bit will be considered as the LSB, and we have to read down. So the binary equivalent of 0.35 will be this. Hence the binary equivalent of 100.35 of decimal number will be this one with some truncation error. This is in brief about the decimal to binary conversion. For more details, we have to continue to number system lecture 3. Thank you.